Hello guys. So today we are going to talk about another type of recursion. It's basically another style of writing a recursion code, right? So it is helper method recursion. Let me zoom in a little bit. So in simple words, if I try to describe it, it's nothing but like you write a function, a recursive function, okay? You use it as a helper method inside of another function, okay? So earlier in the previous code, what we have done is we have created a function, but we were directly calling it, right? We were not using it inside of any other function as a helper method, okay? But here I'll show you an example of how we can use a recursive function as a helper method, okay? So it's nothing complicated, guys. You just have to create a recursive function which will be used as a helper method or a helper function for another function, okay, which we can use to take help, in simple words, right? So this is what we call like helper method recursion, okay? So we have a question here right now, like find square of the array of the numbers passed as an input, okay? So what we have to do, we have to create a function which accepts an array of numbers, okay? So 1 2 3 4 5, and then what we have to return as an output, we have to return 1 4 9 16 25, which is basically square, okay? So what are all the things which we can do? First thing we have to keep in mind, to square it, we have to find out like how we can square these numbers, right? So in JavaScript, luckily we have an operator available already which can square these numbers easily, okay? So let's pick 4, okay? So if I pick 4, if I use double asterisk and 2, okay, it will give me the square of this number, okay? I think it's not zoomed enough. Let me zoom it, okay? Now I think you guys can see it, right? See, 4 double asterisk 2 is giving me the square of that number, right? So if I try it with the 5, let me try quickly. Here also it is giving me like 25, right, which is basically the square of 5, right? So let's create a function, okay? It is going to be the parent function, and inside of this we are going to write our helper function, okay? I'll uncheck the autosave, guys, otherwise it will be annoying, right? So function, and then let's say, or what we can say, convert square numbers, okay? You can change the name of the function for the sake of example only. I wrote this name, okay? Please don't mind. So yeah, here what we have to do, we have to pass num array, okay? So here we will maintain a variable, okay? We will maintain an empty array. Let num array. So what it will do, it will basically hold the squared numbers, right? So that is what we are going to store here, because anyhow, like we have to pass the numbers. After squaring them, we have to push it into some array, right? We cannot manipulate the original array, right? So so here we let's consider we have stored all the elements in the array, in all the squared numbers in the array, and then we return it at the end, right? So this is what this parent function will do, okay? Right now we will create a function which will help this parent function to convert all the elements into the squared numbers, all the numbers into the squared numbers, and to push them into this array, okay? So let's create a function uh, square num, let's say, okay? Here also we'll pass the same thing, num array, and then what we will do, we will simply call this function outside here, okay? And by now I hope you guys know already why I'm calling this sorry, why I'm calling this inner function outside of it, like within the parent function, okay? Because whenever we are calling this function, okay, we have to like call this function, this inner function, some at some point, right? Then only it will start running. We have to give it a start point, we can say, okay? So right after writing this function, we will call this function in order to start this function to work, right? Now let's write our logic here. So let's start with the base case, or we can say edge case handling, which is one of the most important thing in recursion. And I've told you already like why it is an important thing. Okay, and we'll discuss a little bit more about that in one of the future lectures, right? So don't worry. So return the array. Okay, so return out of the function if there is no length. Okay, okay, so if there is no length, we will simply return out of this function. Or what we can do, we can simply take the first element of the array which we are passing. Okay, number at position 0. We don't worry about the rest of the numbers in the array. Okay, you have to keep in mind, and I've already illustrated this in an example, I guess, in one of the previous lectures. There I have just shown you like with the array. I haven't shown you with the code example, right? So this you can consider is a code example of that explanation. Okay, so number at position 0, we have to convert it into the square, right? And then what we have to do, we have to simply push it into the square num array. Okay, it's simple as that. So far what we are doing, we are passing a numbers array into this function. Okay, in this recursive function, where we are checking if there is no length in, if the length of the array is empty. Okay, if there is no element in the array, then we are going to simply return that return out of that function. Okay, otherwise what we are going to do, we are picking the first element of the array, we are converting it into the square. Okay, square number of it, and then okay, so here instead of I've called it like a function dot push. Okay, so here we are converting that into a square number, and then we have to push it into the empty array which we have created in the parent function, right? So far so good, right? Let me quickly format it a little bit so you guys can see what's going on. Okay, so now here what we have done, we have checked the length, we are picking the first number, we are squaring it, and we are pushing it to the this empty array, right? Now what's next? What we will do, we will again call this function, right? So this time what we will do, obviously it is a recursive function, so it is going to call itself over and over again, right, until the array gets empty. Okay, so now we have to think about that. So what I am going to do is, like, I have already took the first element, right? So what I will do, whenever I'm calling this function with a new array, okay, I will simply remove the first element every time because I have already squared it and I have already pushed it into the array. Okay, so for that I can use slice 1. Okay, so basically what will happen, in the first call it will we are passing this whole array. Okay, in the second call we are passing array with these numbers. Okay, in this third call we are passing these numbers only in the array, and then fourth call these numbers, fifth call these numbers, and the sixth call will be empty array. There will be no elements. Okay, so in that case it will simply return out of that function. Okay, so this is what we are going to do. And as you can see, our recursive function, our helper method, recursive helper method we can say, is ready right now, right? So let's test it quickly whether it works fine or not. Okay, I haven't saved it, so yeah. So let me stretch it a little bit so you guys can see what is going on. Okay, so here I'll be passing this whole array, right? So let's see how it goes. Okay, great. So as you can see, I am getting 1, 4, 9, 16, 25, which is the output, right? So this is how we can use a recursion function as a helper method, right? What you can do, like, you can experiment with it, right? So short and simple, helper method is a function which can be used to help some other parent functions, right? There is nothing much complicated in it. Okay, so here I'm simply writing a recursive function which I'm using to help this parent function to convert all its values into square numbers, right? There is nothing complicated in it, right? So this is also one of the design patterns which we use when we are working with recursions, right? So whenever you hear the term like helper method recursion or recursion in as an helper method, don't get confused. It is nothing. It is just using a recursion function as a helper method or to help the parent function or wherever we are going to call that. Okay, inside of any other function. Okay, so this is what we call a helper method recursion. Okay, and this is also like a well-known design pattern in recursion, right? So yeah, this is it for today's lecture. In the next lecture, we'll discuss about another pattern. I'll try to find another pattern. If there is one, then I'll explain you that. Otherwise, I'll talk about the pitfalls which we have already seen in one of the previous lectures in a little bit detail. Okay, and the edge case, why we handle the edge case. Okay, everything we will talk in a little bit detail. Okay, so yeah, this is it for this lecture. uh, by the way, I'll attach this snippet in the description, so make sure to go check it out, right? So yeah, this is it for today. See you in the next one.